Hey everyone, so this will be the summary of our transformations from y equals to fx to y equals to 1 over fx. And the main idea is we follow a comma b becoming a comma 1 over b. And this would happen if b cannot be 0. Basically, this includes our y-intercept and any point other than the x-intercept. Alright, so this is the idea right here where the corresponding point AB will become corresponding point A comma 1 over B. And let's move on to the more general transformations to more specific transformations. Alright, and we start with the idea that if fx is positive, then y equals 1 over fx will be positive. If fx is negative, then 1 over negative would still be negative. Alright, but now we explore the idea if fx is increasing and decreasing. Now, you can look at it this way, right? When you're sketching 1 over fx and you're given y equals to fx, if y equals to fx is basically the graph of the denominator. Alright, so if fx is increasing, let's say this way, then you know that your graph is decreasing because your denominator fx is now increasing. 1 divided by an increasing denominator, your value is getting smaller and smaller. As such, your value is decreasing. Similarly, your denominator is decreasing, your value is increasing. As simple as that. Alright, so we're looking at the value of our denominator and how it changes when we are sketching fx to 1 over fx. Alright, now speaking of increasing and decreasing, we have our minimum and maximum points. Again, not including x-intercepts. If we have minimum and maximum points, it would then be maximum and minimum points with the same idea. If in our minimum point, we have our denominator decreasing, which means that our value is increasing. When then we have our denominator increasing, our value is now decreasing. Conversely, if we have a maximum point, our denominator is increasing, that means now we have a decreasing. Our denominator then decreases, our value then increases. You notice that our point becomes maximum to minimum afterwards. Alright, so that's the whole idea there. Now, next up, we talk about x-intercepts and our exosymptotes. Okay, x-asym, let's say at x equals to a. What happens? Now, we have known that if x equals x-intercept, let's say at a comma 0. Right, what happens? Now we know that if b equals to 0, now we have 1 over 0 as our 1 over fx value. We cannot divide by 0, which means that we now have a undefined point. Which means that, similarly, we just know that if we have a point that's undefined at a particular x value, that x value will become our x-asymptote, which is now x equals to a. Conversely, if we start off with an x-asymptote at x equals to a, that means our graph was 1 over 0. Alright, quotation marks. Now we have reciprocal 1 over 0. This then gives us 0. Alright, as such, we now have an x-intercept because our y value is now 0. Alright, so that was what happened to our x-asymptote. Now, again, we look at our y equals to fx to y equals to 1 over fx, but now we're looking at the horizontal asymptotes. So first up, we have our horizontal asymptote at, let's say, y equals to b. What happens? Now, your graph is now approaching a certain value y equals to b, either from on top or from below. That means your values are approaching b. Now if we take the reciprocal, your values will now be instead approaching 1 over b. Alright, that is the truth, right? Your denominator approaches b, your value would then approach 1 over b. Therefore, we have another horizontal asymptote. Let me get rid of the bottom graph first. At y equals to 1 over b. Horizontal asymptote at y equals to 1 over b. Now, of course, b cannot be 0. So what happens when we have a horizontal asymptote at y equals to 0? Thereafter, we know that now our value is now approaching y equals 0. And we know that as our denominator approaches 0, our value would be large, and larger, approaching infinity. As such, there are actually two cases. The first case being y approaches plus minus infinity. Why plus minus? If this y equals to 0, which is the x-axis, your graph can approach from this way or that way. So it's either approaching from positive infinity or approaching towards from the positive side or approaching from the negative side, which means that it results in positive infinity from the above and negative infinity from below. As such, it's plus minus positive or negative infinity. Otherwise, it's actually a oblique asymptote. And which one is which? Frankly, you rarely see y equals 0 asymptotes, but if they don't give you the exact equation, or if they don't tell you that there's an oblique asymptote at the end, take it as y approaching plus minus infinity. Alright? Now, speaking of oblique asymptotes, we have what happens if we have an oblique asymptote. Now we know that oblique asymptote, your value approaches infinity, right? Something like this, or this, correct? And you notice that your value either approaches negative or positive infinity, which means that now we have our denominator approaching a very, very, very large value. Our 1 over fx would be approaching 0, either from the positive or negative side, again, depending on the graph. Alright, so that's the idea. Now, what else? Now, there's one last part. What happens is, if fx approaches infinity, we know that if fx approaches infinity, that means our denominator gets larger and larger and larger. Our our value of 1 over fx will now approach 0 as well. Therefore, we have two horizontal asymptotes, y equals 0 at a few cases, and these are the cases. Alright, when we have an oblique asymptote, where the idea that fx approaches infinity, and also the basic idea when fx approaches infinity. Right, our denominator approaches a very large value, 1 over a very large value approaches 0. And these are the changes to our fx to 1 over fx graph. Alright, so it's actually very simple. You just need to consider, is this part approaching infinity, or is this part approaching 0? And then what are the corresponding changes to that? Alright, so there we have it, the summary of our transformations to our reciprocal graph.